All right, so the do now question today is what is photosynthesis? All right, so as you know, I said this is kind of out of order, but it's sort of a review of last year. You should have learned this last year. And also, in January, we're going to talk about energy sources. So the sun has a lot to do with what we're going to be talking about in January. So as a review, what is photosynthesis? Eric?
Photosynthesis is like how plants make food, or like they take nutrients and sun and water, and they make food for themselves and survive.
Good. Anybody else want to add anything to that? Naveed?
I think they make sugar.
Make sugar. Okay. What do they need? I mentioned it a few minutes ago. Rachel?
They take in CO2 to make, and then they expel oxygen.
Very good. Okay, so there's an equation. Anybody remember the equation?
Isn't it CO2
Come on.
times?
I think it's C6H12.
We learned this.
So what is
C6H12O6 is glucose.
good? So what uses the process of photosynthesis? Can we lay out in the sun and use photosynthesis?
No.
Only plants.
Only plants. Now they are doing some research. There are some microorganisms that might be using photosynthesis, but that's beyond. When you get to high school and college, we can talk about that. But when we think of photosynthesis, we think of plants. What do they need to have this process happen? Sunlight.
Water.
Okay, that is what is kind of the energy that is being provided to have that happen. So what do plants need before photosynthesis can happen?
Carbon and
Water.
Light.
Not water.
Carbon
Well, water,
dioxide.
yes, but not.
carbon?
Carbon dioxide.
What kind of carbon? That's
Carbon
what I'm saying.
dioxide.
Carbon dioxide.
We already say that.
Okay, and then it produces. Kamal said.
C6H12O26.
And what else does it produce that we need?
O2.
All right. What do you notice about these numbers underneath the elements, though? Do they match up on both sides?
No.
So we have 12 hydrogens here. How many hydrogens do we have here?
Two.
What do we need to do to make that 12?
O6.
Very good, Brendan. So we will put 6 here in the front. So 6 times 2 is 12. 6 times 1 is only 1, or 1 is 6. And then this is 8. On this side, we already have 6 and 8. Okay, but now we have 6 here.
So 60.
So we need 6 in the front. So that now makes 12 more oxygens. Where else do we need a 6?
No. Just for the C though.
You can't split
But CO2.
the CO2, you can't split it apart. So we need a 6 in front of the O2. All right, and that's balanced. Anybody remember the other process that we have, animals have in their system? To kind of create a circle or a cycle.
It's like
Respiration. And basically, and it happens in our cells, it's called cellular respiration. When you hear the word respiration, you think of breathing. It's involved, but it's a little bit different. And we take the sugar, the plant sugars, and we eat them. If we don't eat the plants, we eat the animals that ate the plants, and we breathe in the oxygen. We release
CO2.
the CO2 and the H2O. And some people say, well, how do we release H2O? When you're outside in the cold in the winter, you can usually see your breath, and that's because of all the water molecules being released as you breathe. So, what we're actually talking about today is carbon dioxide and how much we contribute to the environment. Do you think really us breathing out CO2 is really going to have a bad effect on the environment?
No.
No. What are we doing to the environment to create more CO2?
cars.
Brian?
Burning fossil fuel.
Burning fossil fuels?
Cars burning gas.
Cars using lots of gas. What else? Rachel?
Well, factories that are like have lots of like smokestacks and things.
Yep. So factories. Everything that we buy is usually made in a factory. Brendan? Trash. Okay, so it relates back to the 4 questions you had to look up or ask your parents last night for homework. So one was how many miles. So How much are the cars used in your family and how much CO2 are they producing? The second one was how much do you recycle? Now that's a little bit more tricky, we'll come back to that. And then we have heating and electric. Why heating in your house? It's burned. It's either oil or natural gas. Some people have electricity, so that would be more in the electricity part. And what do you have in your house to make sure that you don't have too much CO2?
Isn't it the detector?
There's a
You
lot.
have a detector. Why would you not want to have a lot of CO2 in your house?
Because you can die by it.
It's basically, it could suffocate you. It actually blocks out the absorption of oxygen so that your body's not getting oxygen. So we need to make sure that we have less CO2 in our house, but you do burn it and create CO2 through your heating. Electricity. Why electricity? That seems like a nice kind of non-pollutant kind of thing.
Not like fossil fuels?
Most of our electricity comes from factories that burn fossil fuels, okay? We don't get a lot of electricity from sunlight or from wind. There's a whole bunch of debates going on about that. All right, back to recycling. Does anybody know where your trash goes if you don't recycle it?
Goes into like
Do we have dumps anymore? Can you drive to Malden dump?
No.
No,
Well, there are dumps though.
there are dumps, but
not around the cities. There's no dumps in the cities.
ocean. The rest litter.
People get in trouble if they dump things in the ocean.
But they still do it.
It's over in Lynn/Saugus. Anybody know what that big building is?
The flattener.
It's called an incinerator.
They burn.
Okay, it's called. The company is called Resco. If you're over the highway over there, you can see its big giant smokestack. Why is that not good?
Because it releases a lot of carbon dioxide.
They do have. They're called scrubbers, and they make sure they clean it. But for the most part, they do release CO2. So if you keep a lot of that trash out of going to the incinerator by recycling it, you're gonna have lower CO2. Okay? I'm gonna just show you a quick clip about CO2 over the years.
Brendan, take notes.
Wow.
All right, a lot from the beginning is basically they're looking back at when factories and stuff started producing CO2, so they're not sure. But as you get closer to the 1960s, those are actual amounts. So where do you see it?
I see white and black.
The blue. Where's the blue?
Blue spread up in the England.
Around England, Europe.
Oh, this is the dates.
Yeah.
Oh, England.
That's turning green.
Woo,
Now it's turning
England.
green. That means more CO2.
Yellow.
Yellow.
Now blue's going through. No, Germany, France.
Oh, look at America.
U.S. is on the map there.
Oh, America.
Oh, it's
Oh, God.
there's not really any
Oh my God, look at Europe.
stuff coming
Oh, my
from
God.
over
No,
there in
Asia.
the corner.
Look at Massachusetts.
We'll get as bad as them eventually.
Look at Africa.
There's some near.
How did they get down there?
Oh, there's some near.
Going in a boat.
Oh my God.
What happened to
All
us?
right, so I'll go back to the latest was 2002, I think.
Oh my God.
Oh, 2000. Oh, went fast. All right, never mind the words there, but so the U.S., Europe, Asia, and India, and South Africa. No, not South Africa. Down the southern part of Africa. A little bit. South America's kind of catching up. Australia's catching up. But it's basically right across the middle here. We're producing the most CO2. Okay? The U.S., of course.
But like our in Massachusetts, right? Europe. They're so hot in Europe.
I thought Europe would produce similar.
All right, so the
Europe is known as.
assignment we're going to do, it's called Are You Meeting the Kyoto Protocol, Calculating Your Carbon Dioxide Footprint. So we're going to actually calculate the amount of carbon dioxide you contribute in the atmosphere every year. Okay, we're going to figure that out. So your goal is to see how much carbon dioxide you're actually contributing, and then the second half is how are we going to reduce that. We might not get to that today. How many people have heard of the Kyoto Protocol before? Just
think so.
one person? Anybody have an idea of where it is? It's in Japan.
Oh, I could hear
Have you heard of the carbon dioxide footprint or CO2 footprint before?
Yeah, like.
Okay, so it's just kind of an easy way to kind of say, how did you leave that info on the earth? So a footprint, sort of what trace amount of CO2 are you leaving? All right, when you get your paper, just put your name on it.
Goodbye.
Too late.
I could use another. Standing on 1 foot.
All right, who would like to read that first paragraph? Arthur.
Yeah. Wait a minute. Okay. I got it. Okay. You're supposed to write me.
Yep, read it.
Okay. The Kyoto Protocol is an international agreement written by the United Nations Framework Convention on Climate Change to limit or reduce the emission of greenhouse gases. Carbon dioxide is one of the gases addressed by this protocol. The recommended amount of carbon dioxide emissions per person is 5.5 tons per year. 1 ton equals 2,000 pounds.
God.
How much carbon dioxide do you produce a year? Can you reduce the number?
All right, what does the word emission mean?
Letting out.
So of the gases that are out there, you emit a gas. Okay, so that's what emissions is. Greenhouse gases are CO2, methane, different things like that. All right, look at the second sentence. The recommended, second to bottom, recommended amount of carbon dioxide emissions per person is 5.5 tons per year. 1 ton is 2,000 pounds. Circle that amount. That is the average amount each person should produce if we were to follow this.
So if we produce like 7, is that bad?
Yes.
Well, we'll see. All right, and then so we're going to actually see how much you produce and then how we can reduce it. Purpose, students will calculate the amount of carbon dioxide they individually contribute to the atmosphere every year. Materials, you'll have calculators on the lab tables, and then I put together these nice little wheels. Okay, so this is going to help you find the information.
Wheel of Fortune.
Sort of. All right, procedure, part 1, what's your score? So before we figure it out, we're going to make a hypothesis about the CO2 that you produce every year. Who remembers what a hypothesis is? Netta?
It's like a guess or what you think is gonna happen.
So an educated guess about what you think is going to happen. There should be 2 parts to a hypothesis. I know Mr. Moorhead taught you this. Carla?
Isn't it an if-then statement?
An if-then statement. So you say something and then you have to back it up with something else. So if the average amount is 5.5 tons, you are going to pick a number. How much do you think you emit into the atmosphere of CO2? Do you think it's the same, 5.5 tons? Do you think you do more? Do you think you do less? And then give a reason why. All right, you're going to write your hypothesis on the back of this first page where it says hypothesis. So do that right now. When you're done, put your thumbs up so I know you're done.
How do you do an if-then statement about me? If I calculate,
If I
if I produce this much, then I will be over.
or what if you said if I play more video games, then I will
Get more education.
I will produce more CO2 or something like that.
Smile, you're writing. You need to write a hypothesis right now.
Yeah, going.
No, you write the tons amount. So the average is 5.5 tons. Do you think you create 10 tons? Do you think you create only 2 tons? Nana?
So we have to I'm gonna write 100 tons, that's okay. So if the average is blank, if the average is something, and then I
Think I produce this much.
wait then.
Oh, I did mine different.
If that, how do you put if then?
If the average is 5.5 tons,
Then I just-
then I produce this much because, right? I know the reason you produce it, so. You're on the computer all the time. Or your lights are on while you're reading.
Hard to read in the dark.
Oh,
I have a nook, but without.
Alright, put your thumb up when you're done so we can move on. It's okay, so just kind of group, you know, choose the date. Robert, you okay back there? Done, or you need help? All right, looks like most people are ready to move on. So while you're on this page, quickly look at the chart there. All right, you are going to use the information you collected for your homework last night in filling out this chart. But the way the answers are stated on the wheel is a little bit different. So it'll say, do you do 0%, 50%, or 100%? So of different things, or say number of miles. So you have to read what it says in this top box first, and then look at what you wrote down and kind of correlate the data, okay? So if for the first one, how many miles do you drive your car per week? Remember, if you have more than one vehicle, you have to multiply that times the 2 vehicles. All right, so I'm not gonna use Leon's because that's such a high number. So say your parents drive 250 miles per week. You look at the wheel, you turn to where it says transportation, and it says, on average, how many miles do you put on your car or cars per week? If you have more than one car, use the total number of miles per week for your cars. So the choices are 200 miles, 400 miles, or 600 miles. So if you use more or less, you kind of have to adjust the amount of CO2 emissions. So the choices for CO2 emissions are 10,800 pounds, 21,600 pounds, 32,300 pounds. All right, so you'll have to adjust the amount depending upon your numbers.
So does it, like, what's the lowest amount that you said that?
Was 200.
Miles?
Yeah.
I don't go that far.
So good. So that would mean,
Wow.
so, which is really good. So Eric just said his mom walks everywhere. That is excellent. So your amount of CO2 emissions is going to be very, very low. So you have to adjust the amount.
Mom says
And I'll
about
come around and help you
150.
when you get to that. So once you figure that out, you would put it in the chart. Okay, where it says waste disposal, you write estimated household amount, CO2 emitted per year. You find the CO2 emitted per year here in the little box, okay? And you'll understand more once you get the wheels in your groups. All right, turn back to the directions. So put a check mark next to one. We made our hypotheses. Anybody want to read theirs? Kamal, go ahead.
Oh, no, they see me.
Go ahead, Kamal. It's okay.
If the average CO2 emissions is 5.5 tons, then I produce 6.2 because my language has a lot of has, and hellos.
So you think that's a good response?
No.
So what in your life do you use that produces a lot of CO2? No, that's why he has to fix
No,
it.
it doesn't. When I heard it, I thought it was for
So
like you
looking-
specifically, like not like the things you
Yes, so
use.
looking at those 4 choices, what do you use a lot of in your household? Electric.